1.3, we're talking about complex numbers, the quadratic equations in the complex number system. So this is where we're introducing imaginary numbers, okay? And we denote those by the letter I. And these are numbers whose square is a -1, okay? That means I squared is equal to a -1. And that's probably one of the most important things we're going to have to remember about the i's. Complex numbers are always written in this form, a plus bi, which is called the standard form for complex numbers. The real number a is called the real part of the number. And you have a plus bi, where I is the imaginary unit, okay? When a complex number is written in this form, a plus bi, it is in standard form. It is written in standard form. So you do have to recognize that they use the word standard form a lot for, they mean different things for different types of problems. In the complex number system, standard form means a plus bi. Any number in the form bi is called a pure imaginary number. Okay? So example 1, we have simplify using imaginary numbers. The very first thing that you should do when you have an even index, and notice that these indexes are even. They don't have any numbers showing, so they're understood to be a 2. So these are even indexes. And if you have an even index, you cannot have a negative number under an even index. So the very first thing you do is to pull out the negative. And when you do that, that becomes an I. Then you simplify the number. So if I broke down 49, factored it out, my index is a 2. I'm looking for numbers in sets of 2. For every set that I get, one of these numbers gets to come out to represent that set. Whatever I bring out in front of the radical gets multiplied together. So I have 7i as my final answer. I didn't have anything left over, so that's simply my answer. For the next example, example B, again, even index, pull out my I, factor the 27. This is 9 times 3. If I don't recognize that 9 is a perfect square, then I can keep going. That's 3 times 3 times 3. Bring that one down. Don't leave it hanging. My index is a 2. I'm looking for numbers in sets of 2. For every set that I get, one of these numbers gets to come out to represent that set. This one doesn't have a partner, so it has to stay in. So whatever I bring out in front of the radical gets multiplied together. Whatever's left over inside the radical gets multiplied together, but all I have is a 3. So I have 3i. Sorry. The I should go at the end like a variable. So this should be 3 square roots of 3i. Okay. On example C, again, even index, we have a negative under there, so this becomes a complex imaginary number. Take out my I first, factor out the 125. If I think of this in terms of quarters, that's 5 quarters. I can factor this out some more. I'm looking for things in sets of 2. So for every set I get, one of these numbers gets to come out to represent that set. This one doesn't have a partner, so it has to stay inside. This is brought out in front of the radical. So I have 5 square roots of 5i. The I should go at the end like a variable. Okay. Example 2, write each of the following in standard form. Standard form means a plus bi. When you have complex numbers like this, they cannot be written as one fraction. They have to be separated into 2 parts. You have to have the constant away from the imaginary part. Now, please don't make the mistake of thinking you can multiply these 2 negatives together. That's the first thing most people do. You cannot do that. You have to simplify the radical first. Okay? So, when you have a negative under an even index, you have 4 minus I square root of 36. So if we simplified the square root of 36, broke it down, that would be 6 times 6. So one of these 6's would get to come out to represent this 36. So this will be 4 minus 6i. And this is in a plus bi form. Okay, the constant goes first, the imaginary next. So don't make that mistake. Alright, on this one, again, simplify your radical first. Take out your I. Factor the 32. 30 factors of 32 would be 16 times 2. 16 is a perfect square, so 4 gets to come out of there. The 2 has to stay inside, so I have minus 5 plus 4 square roots of 2i. And that would be my final answer. I cannot put constants together with imaginaries. Okay, they have to be separated. Over here on this one, pulling your I out first. Factoring the 25, that's 5 times 5. I have one set of 2, so 1 5 gets to come out of there. So I have 3 minus 5i. I didn't have anything left over, so that is my final answer. Okay. Equality of complex numbers. A plus bi is equal to c plus di if and only if a is equal to c and b is equal to d. Okay. The sum of complex numbers, if I added these together, this would be numbers with numbers. This would be imaginaries with imaginaries. Okay? And the difference, again, numbers with numbers minus imaginaries minus imaginaries. Okay? Grouping like terms. Okay. Next page. Example 3. 1.3 notes. Okay, so at the top here it says perform the indicated operation. We're adding and subtracting complex numbers. Now, in addition and subtraction, the first thing we need to do is clear the parentheses. And I like to stack my like terms so I can see what I'm combining. So if nothing is affecting my parentheses, I don't have a number out in front of the set of parentheses, I can just rewrite this problem without parentheses. So I would have 4 minus 7i plus 6 plus 3i. Notice that I stacked my like terms. So I would end up with 10 minus 4i as my final answer. And I am writing this in a plus bi form, okay, because these are complex numbers. So again, when you have a plus sign between two sets of parentheses, nothing is affecting these if I don't have a number in the front of the parentheses. So I'm just going to rewrite this without the parentheses and combine my like terms. So I have minus I plus minus 5 plus 2i, a plus bi form. Now, when you have a minus sign in front of a set of parentheses, that's the same as saying I have a minus 1 there. So if you need to see the 1, go ahead and put it there, and do recognize that you do have to distribute this to the second set of parentheses. Nothing is affecting the first set, so I'm just going to write this out. Now, to clear the parentheses on the second set, I have negative 1 times the 3, which would make it negative 3. I have negative 1 plus 6i, which would make it minus 6i. Be careful with your signs here. So my final answer would be 3 minus 15i in a plus bi form. Okay? Example D. Again, I have a minus, and that is shorthand for minus 1. So I am distributing the minus 1, which means I'm going to have sign changes. Nothing is affecting the first set of parentheses, so I'm going to rewrite the first set of parentheses without parentheses. Minus 1 times 2 is a minus 2. Minus 1 times a positive 7i is a minus 7i. Combining my like terms, I have minus 6 plus I. Final answer, A plus BI form. Okay. So on C, we have radicals on inside the parentheses that need to be simplified. So again, I have negatives under even indexes. Square root of 36 is 6 times 6, so I get to take a 6 out of there. So this will be 5 plus 6i plus, and over here, I take out the negative. This would be 7 times 7. So I get to take a 7 out of there. That would be 2 minus 7i. Okay, nothing's in front of the parentheses, so I'm just going to rewrite it and stack my like terms. My final answer, 7 minus I in A plus BI form. Okay, that was adding and subtracting with the imaginaries, the complex numbers. Product is multiply. Okay, so if you don't know what that is, product means multiply. Now we're going to be multiplying these, and this is where we have to really be careful, because the most important thing we have to remember here is I squared is equal to negative 1. So when we FOIL this, we get AC plus ADI, A times C, plus A times DI, plus C times BI, plus BI times DI. Okay? So we just have to be careful when we're foiling here. Make sure you understand what to do when you foil. Now they're introducing a word here. It's called conjugate. And this is kind of like what we did when we worked on the difference of squares. This means the same exact terms with opposite signs. Same terms opposite signs. Okay, so when you see that bar up there, that's what the conjugate means. So if I'm using the same terms, that's A and BI, the opposite sign is always the one that's in between them. Not the one out in front here, but the one that's in between them. So be careful with that. So Z bar, okay, Z bar. When you see this bar, that indicates conjugate. So the product of a complex number and its conjugate is a non-negative real number. When you multiply those two together, you should get a real number, okay? So if we're multiplying the original times its conjugate, that's like saying A plus BI times its conjugate would be A minus BI, okay? If you work this out, this is A times A minus A times BI plus A times BI minus BI times BI, okay? So if you did this, you would get A squared. The middle terms would cancel out, and this would be minus BI squared. And you got to remember that I squared is -1. So there will always be a sign change here. So you would have A squared minus B times a -1. So that A squared plus B. So these would be numbers that you would add together, okay? So you would come out with a non-negative real number. And this is just, see the difference of squares if you don't remember the pattern, difference of squares. So that's what we did, okay? So example 4 says multiply complex numbers, okay? So on example 4, we're multiplying here. On this first one, we're distributing. And again, remember, the most important thing is I squared is equal to -1. Don't forget about that. We have 9i times 4 plus 9i times 5i. I'm writing this out so you'll understand how I'm distributing here. So this is 36i plus 45i squared. Now remember, we said we got to remember that I squared is -1. So there will always be a sign change with this. So right here, instead of a plus 45, this would be a minus 45. Now this is not in the right order. It is not in A plus BI form. The constant has to go first, and then your imaginary goes after that. Okay? Example B, again we're foiling. So we're taking 6 times 3 plus 6 times I. And then we've got minus 3 times 2i, so I'm going to put that here, minus 2i times 3, and then we have minus 2i times I. So 6 times 3 is 18. We've got 6i, and we've got a minus 6i, and then we have a minus 2i squared. And we got to remember that I squared is -1. These middle terms cancel. So we have 18 minus 2 times the -1, which is 18 plus 2, which gives us an answer of 20. Now, sometimes in Pearson, if they really wanted an A plus BI form, this would be 20 plus 0i. But I think they'll take the number as your answer there in Pearson. Okay. On the last example here, again we're foiling. So I have minus 4 times 2 plus minus 4 times 7i plus 8i times 2 plus 8i times 7i. I ran out of room there. So I have minus 8 minus 28i. And here I have plus 16i. Notice that I'm stacking my like terms. And then I have plus 56i squared. And remember, I squared always changes to a -1, so we're always going to have a sign change associated with this. So minus 8. The difference here is minus 12i. And this would be plus 56 times the -1. So minus 8 minus 12i minus 56. Here's two numbers that I can put together. So that's minus 64 minus 12i. And that is in a plus bi form. Okay? Be careful with these when you're foiling. You just got to make sure that you take your time with those. So example 5. We're multiplying complex numbers, complex conjugates. Okay. Find the product. You got to make sure you understand that product is multiply of 6 minus 9i and its conjugate. So if we have 6 minus 9i, its conjugate is the same exact terms with the opposite sign. Okay? So if we're foiling this, remember we should get one real number. 6 times 6 is 36 plus 6 times 9i is 54i minus 9i times 6, which is a minus 54i, and a minus 9i times a positive 9i gives us a negative 81i squared. Now notice that these terms in the middle cancel out. So we have 36 minus I squared becomes a negative 1. So 81 times negative 1, which means there's going to be a sign change here. So we have 36 plus 81. And our final answer, 117. Okay? This is a pattern. So you know that you squared the first term, you squared the last term, and you changed your sign. That's a special pattern. Square the first term, square the last term, and change your sign. If you're multiplying anything by its conjugate, that's a pattern there that you can use, that you can recognize to help you work through the problem faster. Okay? So example 6, dividing complex numbers. Divide the following complex numbers. Okay? So when you divide, you cannot have a 0 in the denominator, you cannot have a radical in the denominator, and you cannot have a complex number in the denominator. No 0, no radical, no complex number in the denominator. Okay? So on these we have complex numbers in the denominator. We have the numbers with i's. And to eliminate those, you have to multiply by the conjugate. So the conjugate of 4 plus 3i is 4 minus 3i. And whatever you do to the bottom, you have to do to the top. So if you remember that pattern about what happens when you multiply a number times its conjugate, square the first, square the last, change the sign, you can save yourself a lot of work here. But if you don't, when in doubt, work it out. So we're foiling on the top. So this is 6 times 4, which is 24, minus 6 times 3i is minus 18i, minus I times 4 is minus 4i, and minus I times minus 3i is plus 3i squared. That's what we get in the numerator. In the denominator, if you don't recognize the pattern, remember we said square the first one, square the last one, change the sign. So if I squared the 4, that would be 16. If I squared 3i, that would be 9i squared. And if I change the sign, because I have a minus, that's going to be a plus. Okay? So the sign changes because of this. Alright? So up on top, 24, I squared again changes here. So this would be 24 minus 18 and minus 4 is 22i. This would be a minus 3 because of the sign change there. This is a minus 1. On the bottom, this would be 16 plus 9 because of the sign change there. This is a minus 1. Okay? So 24 minus 3 is 21 minus 22i all over 25. And remember, we cannot write this as one fraction, so you do have to separate it. If you can reduce these fractions, then you reduce them. If not, then that's how they stay. Okay? The conjugate of this one in the denominator here would be a minus 6i. Keep the number, change the sign. And whatever you do to the bottom, you have to do to the top. So up in the top, I'm just really distributing minus 6i to each of these terms. So here I would get a positive 24i minus 30i squared over a minus 36i squared. Now remember we said I squared makes a sign change. So we have 24i plus 30 over positive 36. And since I cannot have this written as one fraction and the order is wrong, I'm going to rewrite this as 30 over 36 plus 24i over 36. And I'm going to reduce each of these fractions. So this one becomes 5 over 6 plus 2 over 3i. And now I have it written in a plus bi form. In case you're having trouble reducing these fractions, 30 over 36, that becomes 6 times 5 over 6 times 6. The 6's cancel, and that's where I get 5 6 from. 24 over 36, if I factor these, this is 6 times 4, this is 6 times 6. Those cancel, I've got 4 over 6. I can change that to 2 times 2 or 2 times 3, which would give me 2 over 3. Okay, factor these. If you're not good at reducing those, just factor them out. And underneath here we have the conjugate of a complex number is the complex number itself. So conjugate of a conjugate is a conjugate. I mean, just a complex number. Sorry. Conjugate of a conjugate is just a complex number. Okay? Conjugate of the sum of two complex numbers is equal to, if you can separate this, the conjugate of the first plus the conjugate of the second. Okay? If you're multiplying them, again, separate them. Conjugate of the first times the conjugate of the second.